In this video, I'm going to solve a combination circuit. So let's have a look at this circuit here. We have a battery right here, so this is the source. Then we have a resistor connected in series with the battery. And then we have two junctions here. So we have this junction and this junction. And these two junctions are connected in parallel. Okay? So the first thing we're going to do is we're going to find the total resistance for the circuit. Usually for these kinds of complex combination circuits, the first thing you should do is find the total resistance. And it's not too difficult to do this because we're given all the resistances. So we're going to begin by finding the resistance, the total resistance for these two resistors. And so these two resistors are connected in series. And so to combine them, to find the total resistance for these two resistors, for R3 and R4, we would just add the two resistances. So R34 is going to equal 5 plus 15. And that's going to give us a resistance of 20 ohms. Okay, so remember that resistors connected in series, all we would do is we would add the resistance values for them to find the equivalent resistance. So next, I'm going to find the equivalent resistance for this resistor, so R2, and the combination of these two resistors. And so R2 and R3 and 4 combined are in parallel with each other. And so if resistors are in parallel, in order to find the equivalent resistance, we would have to do 1 over R, and so the equivalent resistance I'm going to represent by 2, 3, and 4 is going to equal, so 1 over 10, so that's for R2, plus 1 over 20. And that's for this resistance here. Okay, so 1 over 10 plus 1 over 20, and that's going to give us 3 over 20. So R234 is going to equal 20 over 3, which is approximately 6.7. Okay, so 6.7 ohms for the equivalent resistance of R2, 3, and 4. So now that we have all these resistances, what we can do now is we can find the total resistance of the battery. And so the total resistance, RT, for the battery is going to equal R1 plus R2, 3, 4. So R1 is 25. Okay, and R234 is 6.7. So we're going to get a total resistance of approximately 31.7 ohms. Okay, so now that we have the total resistance, so let's put it in the chart. It's always useful to create a chart like this one when solving combination circuits. So the total resistance is 31.7. Now the next thing we're going to solve for is the voltage of resistor 1. So we have the current given to us, 3 amperes, and we're given the resistance for R1. So it's not difficult to solve for the voltage. So to solve for the voltage, so V1 is going to equal I1 times R1. And that's going to give us 3 times 25 is going to equal 75. So 75 volts. So the voltage or potential difference for resistor 1 is 75 volts. So I'm going to write that into the table. So 75. Okay. The next thing we can do is we can find the total voltage or the potential difference across the terminals of the battery. And similarly to the way we found V1, to find V total, it's I total, so the total current, times the total resistance. And the total current in this case is going to be 3. The reason why it's 3 is because since this resistor is connected to the battery in series, if this resistor has a current of 3 amperes passing through it, then there's 3 amperes of current coming out of the battery. Okay, and so the battery has the same current as this resistor, since they're in series with each other. So the total current is going to be 3. Okay, so 3 is the total current. And since we have the total current and we also have the total resistance, we can find the total voltage. And so the total voltage is going to equal 3 times 31.7, and that's going to give us roughly 95.1 volts. Okay, so 95.1 volts, let's write that in. 95.1. So the next thing we're going to look for is the voltage of this resistor, R2. And the way we're going to find it is we know that the total voltage, the voltage across the battery, we know that it's 95.1, and we know that the voltage of R1, this resistor, is 75, and that means that the voltage for this part, for these resistors in parallel, would have to be 95 minus 25. Okay? Because according to Kirchhoff's law, we know that voltages in series will add up. And so, since we're treating R1 and then the combination of these three together, we're treating them, we're saying that they're in series with each other, then we would have to do 25, or not 25, the voltage for V1, which is 75, plus some unknown voltage, is going to give us the total voltage across the battery, which is 95. And so to find V2, we're going to take the total voltage and subtract V1 from it. So 95.1 minus 75 is going to give us 20.1 volts. Okay, so the voltage for resistor 2 is 20.1 volts. And since we have the voltage for it and we also have the resistance, we can calculate the current. So I2 is going to equal V2 divided by R2. So 20.1 divided by 10 is going to give us roughly 2 amps. Okay, so the current is 2. Now, since the current that's flowing through this resistor is 2, and the total current that's entering this junction is 3, if 2 amperes goes into this branch, then only 1 ampere will go into this branch because there's a total of 3 amperes. So then we know that I3 and I4, since they're in series, are going to have a current of 1 ampere passing through them. Okay, so 1 and 1. And now what we're going to do is we're going to find we're going to find the voltage of this resistor. And we have enough to do that. We have the resistance for it and we have the current for it. So V3 is going to equal I3 times R3. So 1 times 5. So it's going to be 5 volts. And now since this is 5, we know that, and we know that this is 20, and these two resistors add up to the same voltage as this one. Then in order to find the voltage of resistor 4, we would just have to take the voltage of V2 of R2, and so that's 20.1, and subtract 5 from it to give us roughly 15.1 volts. Okay, so that would be 15.1. And so we've solved this circuit completely. So we know all the values for it. So remember that in series, you're adding the voltages, while in parallel, the voltages are equal to each other. For resistances, in series, the resistances add up, and in parallel, you have to do, in order to add them, you would have to do 1 over. So 1 over the total resistance is going to be equal to 1 over R1 plus 1 over R2, etc. Okay, so thank you for watching this video. If you enjoyed it and found it helpful, please give it a like, and check out some of my other videos.